Welcome back to the GCSEMathsPro YouTube channel. Today's video is the Paper 1 June 2022 Edexcel Higher Tier. So this is actually non-calculator paper, so make sure you're not using your calculator at any point during this exam, because otherwise what's the point? You might not know what you actually can and cannot calculate when you don't have a calculator. So it's really important to practice each of the exams exactly how you will on the day, whether that's without a calculator or whether that's with the correct calculator for the other two papers. So let's get straight into it. We've got question 1, 7x minus 27 is less than 8. We need to solve this inequality. This is a linear inequality, as in just the same as a linear equation, it's just x. We just need to get x on its own, solve it the exact same way as if it had an equal sign. Just copy the symbol that you've got. So what I would do in that case, I would move 27 by adding it. Obviously, whatever you do to one side, you have to do to the same to the other side. So 8 plus 27 gives you 35. And then the last thing is to divide by 7 on both sides. And because I've copied the symbol, my answer is x is less than 5. It's literally as straightforward as that. That's all you have to do for linear inequalities. Question 2. We're now asked to write 124 as a product of its prime factors, which is prime factor decomposition. So you can use a factor tree, or more specifically a prime factor tree. I normally try to divide initially by prime factors. So I pretty much always start with 2 if it's an even number, so I can half it to get 62. Can I use 2 again? Yes, half it again. 31, then I check what other prime numbers I can use because this is no longer even. 32 itself is prime, so that is just the answer. I can't go any further, so my actual answer is 2 times 2 times 31. Those are the prime factors that make up 124. Question 3. A delivery company has a total of 160 cars and vans. The number of cars to the number of vans is 3 to 7. So I like to put the initials there so I can just see it quickly. Each car and each van uses electricity or diesel or petrol. 1/8 of the cars use electricity, 25% of the cars use diesel, and then the rest of the cars use petrol. We need to work out the number of cars that use petrol. So there's normally always some kind of what I would call a general arithmetic question, as in it's just kind of loads of different fractions, percentages, ratios. We're just kind of multiplying and dividing. So what we need to do first, and a lot of the time it is in order, if you're not really sure what to do, sometimes it's in the order that they want you to do it in, or how you need to use the information. So in this case, because they've told us 160 cars and vans, obviously that's my starting point, but all of this other information is just about cars. So realistically, actually, all I want to know is about the cars. I don't really care about the vans. So I'm going to use the ratio first to split up how many cars there are. So we've got 160. Now, when we split up a ratio, when we share out a ratio, you have to add together the parts of the ratio. So that's 10 parts. And then you divide your total by that. So 160 in total divided by 10 parts obviously gives me 16, either cars or vans per part, doesn't it? Now, obviously, how many parts do I have for cars? I have 3 parts. So then I need to times by 3. So 16 times 3. Actually, I do tend to recommend, and obviously you've got the times tables up to 12, but for the non-calculator, I would recommend just familiarizing yourself with the 15 and 16 times tables. I mean, up to like 5 or 6 times that, not the whole thing. Because I feel like 15 and 16 is used quite often, and it's a little bit easier if you already know that 3 times 16 is 48. So that's how many actual cars there are. Obviously the rest are vans, but I don't really care about that, right? Because I'm only going to be looking at cars from now on. So we've got 48 cars, and then it says 1/8 use electricity, so we need to work that out. Because it's non-calculator, I'm just going to divide by 8, isn't it? Divide by the denominator, and then technically multiply by the numerator, but obviously it's 1, so that makes no difference. 48 divided by 8 is 6 cars. So that's electricity. And then 25%. Now I would use it as a fraction again, just because 25% is quite a nice percentage. That's the same as 1/4, isn't it? So personally, I would just divide by 4. Now, you obviously can work out the percentage, as in let's work out 10%, times it by 2, work out 5%, so on. You can do it that way, absolutely fine. Whichever way kind of makes sense to you. But I'm just going to divide it by 4 to find a quarter, which is obviously 12. So what's that? That's diesel. And then the rest are petrol. Now that's what we actually want to know, isn't it? We want to know how many petrol. So obviously, if out of 48 cars, I just need to subtract the other 2 options. So 6 plus 12, which is 18, isn't it? 48, take away 18 is 30. That's how many are using petrol, 30 cars. Okay, so your final answer should be 30. I scroll down, you see that's 5 marks. It's quite a lot of marks, even though it's fairly basic calculations. 30. Okay, question 4, we've got some standard forms. So write 1.63 times 10 to the power of minus 3 as an ordinary number. So it's a negative power. Now, you can obviously just do it by counting how many times to move the decimal place. When it's a negative power, though, and this is only for negative powers, you can just add that number of zeros in front. So obviously it's a negative power, it's going to get smaller, isn't it? So as in 0.00, that's 3 zeros. Obviously there's a decimal between them, 163. Or if you want to count it, that's also fine. So we need to move the decimal place 3 times, but obviously it's going to get smaller, so that's to the left. So 1, 2, 3, that's where your new decimal place would be. And you see how then that's only 2 zeros in front of the 1, and then obviously 1 in front of the decimal. So whichever of those 2 methods, that's fine, 1 mark. And then we've got the opposite. So write 438,000 in standard form. So obviously standard form is a number between 1 and, I say 10, but it's obviously not including 10, right? 1 and 9.999. So that would be 4.38 in this case, wouldn't it? That's between 1 and 10. Obviously times by 10. And then we just need to work out the power. Now, because our answer here, the 4, is actually smaller than the original, so it's going to have to get bigger again if you wanted to convert it back to an ordinary number. Obviously, it's a positive power, isn't it? Not like the first one. It's a positive power. And then we just count, well, the original decimal place was here. Now it's here. Or if you can always write it out to make it a little bit more obvious. It was here, wasn't it? Now it's here. And you just count how many times you've moved. 1, 2, 3, 4, 5. Or you can obviously count those digits. But this one, obviously, it's not just how many zeros, is it? Because you also had the 3 and the 8 to account for. So just be careful with that. Don't just count the zeros. Okay, part C is 2 marks now. So work out 4 times 10 to the power of 3 multiplied by 6 times 10 to the minus 5. Now, you can obviously convert these into ordinary numbers and then multiply them and then convert them back. But the way that I would do it is I would actually use index laws. So you see how all of these are multiplied? I know there's brackets, but when you multiply any numbers, it doesn't actually matter which order you multiply them in. You'll still get the same answer. So what I mean by that is I'm going to pick out, get my highlighter. You see the 4 and the 6. Luckily they've chosen nice numbers because it's obviously non-calculator. I'm just going to multiply those first, which is obviously 24. And then separately deal with the 10s, because you see how, because they both have the same base number, as in 10, that's like 10 to the power of 3 times 10 to the minus 5. Do you see how this is index laws? So I could simplify that to be 10, and then you add the powers, so that would be to the power of minus 2. And then you just multiply those 2 together again, right? So 24 times 10 to the minus 2. Now, the only thing here is obviously this isn't actually standard form. It looks similar, but it's not, because it has to be, as we said before, between 1 and 10. 24 is not. So either you can just figure out, okay, to make it, obviously I'm going to have 2.4, aren't I? Just figure out how you change the power, or, because this is more simplified, you can actually obviously make it into an ordinary number now, and then put it back into standard form. It just depends how comfortable you are with standard form. So this would be, if I made it smaller, obviously the decimal place is currently here, isn't it? By 1, 2, that would be 0.24. As an actual number, it's 0.24, isn't it? So to make it into standard form, I've actually had to change it by 1, haven't I? But obviously my actual answer is smaller than the standard form version, so it still needs to be minus 1. Okay, so that's how I would do it. I mean, there's loads of different ways, but that's the way that I would tackle it, using index laws. Okay, question 5. Here is a regular hexagon and a regular pentagon. Work out the size of the angle marked X. Now, regular means, I mean, you can kind of see, but you should never really assume it's based on the word regular that they've told us. All the sides are the same length. I mean, individually for each shape, isn't it? So, as in, that's the same as that, it's the same as that, it's the same as that, and so on. And therefore, all of the angles are the same. That's what it just means. It's kind of like a square. A square is a regular quadrilateral, isn't it? Same with the pentagon. Obviously, they have different angles because one's a hexagon, one's a pentagon, but that angle will be the same as that angle, which is the same as that angle, and so on. That's what we mean by regular. So this is actually something that I don't know if you'll remember. This is probably from Key Stage 3, but it's a formula that is really easy to use. Not on your formula sheet, obviously. You would want to memorize it. But you might have forgotten that this even exists. So you're probably thinking, well, I don't know those angles. I mean, if you do, great, but you probably haven't memorized these angles. So for example, you obviously have memorized triangle is 180, any kind of square or four-sided shape, any quadrilateral is 360, but beyond that, we don't tend to memorize them. So we've got a formula that can tell us the total degrees or the total angles in any polygon, any shape. Well, obviously 2D. And that formula is n minus 2 times 180. And it works obviously for triangles and for quadrilaterals as well. We just don't need to use it because we should have memorized those anyway. So, for example, let's do the pentagon because it's smaller first. That's got 5 sides. N is the number of sides, right? Or the number of angles. That's obviously the same thing. So for the pentagon, if you obviously don't have it memorized, I would do 5 minus 3 times 180. Obviously it's non-calculated, so we do have to work this out ourselves, but that's fine. That's the same as doing 2 times, oh, sorry. Put the answer there, 5 minus 2. Obviously make sure you follow the formula properly. 5 minus 2, which gives you 3. 3 is basically the same as 3 times 180. So you can either multiply it or you can add it, however you want to work it out without a calculator. I know that 2 times 180 is 360, and then you can just add like another 100, which is 460, add another 80, which is 540. However you want to work it out, the calculation, that's up to you. So in any pentagon, whether it's regular or not, any 5-sided shape has 540 degrees. Now, because it's regular though, I can therefore work out what each of these angles are, because they're all the same. It's equally distributed, isn't it? So each angle would obviously be 540 divided by the number of sides, which is 5, or the number of angles. Again, however you want to divide this, you can do bus stop. The way that I divided it, just because these numbers were they were just nicer, is I did obviously 500 divided by 5 is 100, and 40 divided by 5 is 8, so I got 108. But obviously you can use bus stop if you like, that's up to you. So in any regular pentagon, all of the angles individually are 108, which is helpful over here, isn't it? If I put that there, 108, see how that's relevant to the x. Now I'm going to do exactly the same thing, but with the hexagon, so I can find out this angle. Obviously, I just need to change, instead of using 5, I'm going to use 6, because obviously a hexagon has 6 sides. Hexagon. So 6 minus 2 times 180. That's obviously 4 times 180, isn't it? So in that case, I did 180 times 2 is 360, and then if you double that again is 720. Again, you can use column multiplication if you like, it's up to you. So that's the total in any hexagon, but because it's regular, I know that that is equally shared out between all 6 angles. So if I divide that by 6, this one's a bit easier because you can do 72 divided by 6, which is 12, and then just add the 0 again, or bus stop. Again, up to you. So that one's 120, or all of them in the hexagon are 120. Do you see how now I've got one more step to find x, because these 3 angles are around a point. So obviously we should know that angles around a point add up to 360. So I'm going to do 360 minus both of those, 120 plus 108, which is obviously the same as doing 360 minus 228. And then you can subtract that by just adding up, or you can obviously do column subtraction. That bit's up to you, however you like to subtract. and I normally add up. So for example, starting at 228, I would add 2 to get to 230. Then I would have to add 70 to get to 300, and then 60. That's how I would do it, just because I don't really like to subtract, but obviously you can do column subtraction as well. Adding those together, you should get 132. So however you've worked it out doesn't really matter, as long as you obviously get that number as your answer, then you're fine. So that is 3 marks, but really nice easy 3 marks if you can just memorize this formula. For any kind of regular polygon question, this is helpful, this formula. Okay, question 6, this is a nice one. We've just got a few different parts. So part A, complete the table of values for y equals x squared minus 3x plus 1. Now obviously if this were a calculator question, there's a way to use your calculator to create a table. It's obviously not, so we're gonna have to work it out ourselves. Now it is a quadratic, isn't it? Can you see? And it's a positive quadratic, so I just want you to have roughly thought of, well, it's going to be roughly this shape, isn't it? The other thing about quadratics is obviously, I mean, my drawing is not very accurate, but they are symmetrical, aren't they? If you were to draw a line like this, they are symmetrical. So at some point you will notice a pattern here, and I'll show you what I mean. So just be really careful with the negatives as well. Obviously you're not using a calculator, so it won't necessarily go wrong, but sometimes when you are squaring negatives, you have to remember that it obviously becomes positive. So they've given you a bit of space to work it out. So we've got y equals, you just literally sub in the values, right, for x. So 1 squared minus 3 times 1 minus 1 plus 1. Just be really careful with the negatives. So that's positive 1. This also becomes positive, plus 3 plus 1. So that becomes 5. And then we go along, so we do the same for 2. 2 squared minus 3 times 2, that's now obviously a positive number, so 2 squared is 4, that's minus 6 plus 1. So that's minus 2 plus 1, which is minus 1. Okay, this is what I'm saying. Because they're symmetrical, do you see how we've hit 2 y values that are the same? This is therefore where the line of symmetry is. So, well, that was a really horrible line, but yeah. So I could obviously sub in 3, sub in 4, but you should know, well, I'm telling you now, obviously, that the trick is that because it's symmetrical, therefore this one should be 1. See how that matches the 0? And then this one should be 5, which matches minus 1. Which I think is also why they haven't given you that much space. So you just work out as many as you need to before you can see a pair of those y values repeated. And then you can figure out, oh, that's where the line of symmetry is. And therefore, I can just copy the values. Or you can work them all out if you feel more comfortable doing that. That's also fine. Okay, part B, really easy. Obviously, if you've answered part A, you just need to plot it. So minus 1, 5. Obviously, we know it should look like a U shape, so if you get anything that's not a U shape, then something's probably gone wrong. 0, 1, 1, minus 1, 2, minus 1, 3, 1. You can kind of see what I mean by the symmetry now. 4, 5, there. And then you obviously join it all up as a curve. That's where our line of symmetry is, isn't it? Basically here. This is the line of symmetry. So that's why I knew I could copy the values, because it's a U shape. Okay, I'm going to try and join it up. Obviously on your piece of paper in real life it's a bit easier than me trying to do it here digitally, but as best as you can. With obviously a pencil. Oh, this is... Okay, let's try. Just because we need to do it also accurately, because part C is going to ask us to use it. So I'm trying to do it fairly accurately for that. Roughly like this. There shouldn't be any straight lines, right? It's just... Oh, this one's proving difficult. It should obviously be a smooth curve if you can make it that. Okay, something like that. It's a U shape, you can see. Okay, can you see part C now? Part C is so easy, a really easy 2 marks, but sometimes people don't really know what it's asking. So this is one to really pay attention to, because if this comes up, it's super nice to get these marks. So it says using your graph, hence why there's basically no working out space, is there? I know there's space here, but you see where the dotted line is for your answer? If you go across, that's just your answer space, really, isn't it? There's no working out space. Okay, so we're not going to do any actual working out. or any calculations. Find estimates for the solutions of the equation x squared minus 3x plus 1 is equal to 0. Now I want you to compare this. Get my highlighter. Do you see this? X squared minus 3x plus 1, and then you see your question, x squared minus 3x plus 1. I know it's like left and right, they've swapped the sides, but they are the same equations, aren't they? Now look at the other side. This is 0, isn't it? Do you see how originally it was y? So what that is saying, and it's not always 0, sometimes they give you a different number, which is why I'm kind of over-explaining it. What that is saying is when y equals, and then whatever number they give you, in this case, 0. Okay, where on the graph is y 0? Well, that's obviously this line here across, isn't it? As I said, if it's a different number, you go to that horizontal line. Whatever number it is, you go to that line, okay? So they've said solutions. You might see it. They also sometimes say roots. If they say roots, exactly the same thing. Solutions, roots. Same word, really. It's kind of a synonym. So find estimates for the solutions. So the solutions, we just want x because we know that y is 0. So we're only looking for x. And you know with quadratics, you pretty much always get 2 answers. That's why they're saying plural solutions. And they're estimates because obviously we're using the graph and the graph isn't that accurate. That's why it says estimates. Okay, so that's why you want to try and draw yours as accurately as you can. So we're looking at where it crosses. Where does my curve, as in the quadratic, cross with y equals 0? Well, here and here. And I'm just going to read those off. Only to 1 decimal place. You don't need to do more than that. Obviously that would, yeah, it's only to 1 decimal place. So mine kind of crosses through at 0.5. Again, remember I haven't really drawn mine very well, but that's fine. So x is 0.5. And I put a little comma. And then here, that one looks more like 2.6. Okay, be careful if you've got any negatives, make sure you write the negative. In this case there aren't, but if they're, if it crossed over here, make sure you write the negative if there is any. So that's literally it, that's your answer. That's literally it. You just have to look at the graph, look at the correct line where it crosses, and then read it off. Now, obviously they do give you a slight range of answers because everyone's curve will be minorly different. So you could get, as long as you get anything between 0.3 to 0.5, I got 0.5. And then the other one is as long as you get between 2.5 and 2.7, so I got right in the middle of that one, so that was fine. As long as you get anything between those. If you did go for more than 1 decimal place, as long as it's between that range, then it's fine, but you only need 1 decimal place. Okay, so that's really a really nice question. 6 marks in total. Okay, question 7. Here are 2 cubes, A and B. They've obviously given us the side lengths. 4 and 3. Cube A has a mass of 81 grams, cube B has a mass of 128 grams. Work out the ratio of the density of cube A to the density of cube B. Give your answer in the form A to B, where A and B are integers, as in whole numbers. Okay, so we want density. That's basically the whole topic, isn't it? The whole topic is density, and at the end, we'll put it in the format of a ratio. So density, you can use the formula, is mass over volume, so mass goes at the top. In this case, we are actually going to work out density, aren't we? So we need to do mass divided by volume. Now, they've given us the mass for both. Therefore, the bit that we're missing is the volume, isn't it? So do you see how before I can do density, I do need to work out, for A and for B, the volumes? But because they're cubes, all of the sides are the same, aren't they? That one's all 3, this one's all 4. So, for the volume of A, we just need to do 3 times 3 times 3, or in other words, 3 cubed. Which obviously, hopefully you could obviously work it out, but hopefully you'd memorize what 3 cubed is. It's 27. And then same for B, but obviously instead we're using 4. 4 cubed, 4 times 4 times 4. Again, should know this, 64. Okay, so that's the volume. Now we can work out the densities for both A and B. So the density of A, make sure you obviously match up the correct mass and volume, is 81 divided by 27. Now, you can obviously work this out by dividing, but actually, hopefully you'd recognise these numbers. We just said 27 is 3 cubed. I would also want you to be able to recognise 81. I know it's 9 squared. Obviously, you know that. But the other thing is it is 3 to the power of 4. So if you've got 3 to the power of 4 divided by 3 cubed, then I can just divide and go, oh, I know that 27 goes into 81 3 times. It's just about recognizing those numbers. They've chosen those numbers deliberately. So that one is 3 grams per centimetre cubed. I don't think you need the units, but just to show you. Density of B, 128 over 64. You can see they've chosen that deliberately as well, because that divides, oh, just to give you a half, literally. Well, as in 64 is half of 128, which gives you 2. And then they've just said, so we worked out the densities. They've then said just put it in this format, A to B, density of A to density of B, and make sure they're whole numbers. Now, 3 and 2 are whole numbers, so all I need to do is just put it into that ratio. Obviously, make sure you put them the correct way round. You should get 3 to 2 as your answer. So you don't need to change that, as in they're already integers, aren't they? They're already whole numbers, and that is also the simplest. So yeah, 3 to 2. The ratio was just the last bit. Density, mass, volume, by the way, that formula you do need to actually memorize. Or the formula triangle, however you want to memorize it, you do need to know that. It's not on any of your formula sheets. Okay, question 8. The table shows the amount of snow in centimetres that fell each day for 30 days. Work out an estimate for the mean amount of snow per day. Okay, this is a really nice question, really easy marks as long as you've memorized the step-by-step process, because it's pretty much always the same. You just have to apply it. So, work out the estimate of a mean. If they ask you that, work out an estimate for the mean, and then you see you've got a table, and then you see how on one of them there's kind of ranges. This is the topic that I would call mean from a frequency table. Clearly, it's a table and it's got frequency in it. So, it's always the same method every time. You need to first work out, you can write an extra column here, or you can put it on the left if you like, a midpoint, because we can't use ranges, we have to have a single value. Which is also why it's an estimate, because we're obviously estimating halfway, when it's in reality probably not likely to be exactly halfway, is it? So, these ones are kind of easy to work out, the midpoints for. If they are harder, or if you're not sure how to work out midpoint, what you can do is just add the two numbers together, as in 0 plus 10, and then half it. It's like an average, isn't it? But I think this one you can probably visualize it. That's 5, 15, 25, 35, 45. So that's the first thing. Step 1, midpoint column. Step 2 is then to do the frequency multiplied by the midpoint. So you see these two columns? You need to multiply all of these. So 8 times 5 is obviously 40, 10 times 15 is 150, 7 times 25, again if you need to use column multiplication you can do that, if you need to add it up that's fine, but because I know that 8 times 25 is 200, I just did 7, which is 175, 2 times 35 is 70, and lastly 3 times 45, I just did 2 times 45 because I know that's 90, and then I added another 45, which gives me 135. That's step 2. Now step 3, this is kind of where it relates more to mean. You know, when you do mean, you have to add them all up and then divide by how many there are. That's what we're doing now. So step 3 is to add them all up, this column here. So we've got, it's pretty helpful if you wrote it in, you know, matching up. So 0, 0, 5, 0, 5, so that's 10. Then we've got 9 plus 7, which is 16, 23, 26, 27. Just make sure you add it up right. Obviously don't want to lose marks because not added it up right. And then that was 20, wasn't it? So we carry the 2. 1, 2, 3, 4, 5. Okay, you should get 570. Last step is we've said add them all up, divide by how many there are. So this is where we're going to divide 570 by how many. Now what was that? That's the total frequency, which is actually in the question, but this bit's technically 30 if you needed to add that up. If they didn't tell you. And then we need to divide this. Now the first thing I would do is probably just knock off the zeros, simplify the fraction, and then you can divide that however you want. I might use bus stop for example, because that's beyond. You could either use the times tables or obviously bus stop. So 3 goes into 5 once, with a remainder of 2, and then 3 goes into 27 9 times with no remainder. So 19. That's our answer, 19. This can come up obviously in the calculator questions in the exams, but sometimes obviously then it would normally be a decimal. In this case they've chosen nice numbers. So 19 should be your answer. But yeah, mean from a frequency table, really nice question because it's just the same method every time, obviously just different numbers. So it's quite an easy 3 marks. Okay, question 9. A cube is placed on top of a cuboid, as shown in the diagram, to form a solid. The cube has edges of length 4 centimeters, and the cuboid has dimensions 7 by 6 by 5 centimeters. We need to work out the total surface area of the solid. Now, again, this is quite an easy one, but it's one where I feel like some students get mixed up with what surface area is, and they think, is it volume? But they get it mixed up with volume. It's not volume, right? Volume is the capacity, as in, if you were to fill it with like water or something, what could fit inside of it? It's not that. Surface area is still an area, which is 2-dimensional. But obviously it's in the context of a 3D shape, which I think is where it's confusing. So there's not specific formulas for it, because it's just you work out all of the individual areas of all of the faces on the outside, and then you add them up. Now, the only thing that we need to consider is, you see this bit here, one face of the cube is not included, and also that creates a cutout on the cuboid, which is also not included. So surface area is just the outside. That bit there that I've just coloured in is technically on the inside, isn't it? So that face, that surface area, we don't need. So just be aware that we were going to cut that out. So we could work out the surface area of the cube. Let's do the cube first. Now, obviously the area of one of the faces is 4 times 4 squared, isn't it? Now, normally the surface area of a cube, normally there are 6 faces, so you would just times that by 6. But we just said we don't want to include one of them. So I'm going to multiply it in this case by 5, because I don't want to include that base. So 4 times 4 is 16, times 5 is 80, or you can multiply in different orders. You should get 80 for the 5 faces that are on the outside. Then we need to do the surface area of the cuboid. And again, just we'll subtract this other bit at the end. So this one's obviously got different faces, hasn't it? So if you imagine the front and the back, that is 7 times 5, but there's 2 of them. So I'm going to times that by 2. Then I need to add that to the left and the right hand side, which is 5 times 6, and there's 2 of those. And the top and the bottom is 7 times 6, and there's 2 of those. But in this case, we don't want this orange bit, do we? Which is a cutout. So then I could subtract that orange bit, which I know is 4 times 4, isn't it? So just remember, you need to cut out any of the bits that are overlapping, that are technically on the inside of the shape. Those don't count towards the surface area. So that's why this one's a little bit more complicated, I guess. Okay, and then you just have to work out all of this, unfortunately. So 7 times 5, 35 times 2 is 70. 5 times 6, 30 times 2 is 60. 7 times 6, 42 times 2, 84. And then obviously 4 times 4 is 16. Add them. Just trying to pause whilst they're drilling above me. So add them up. Obviously that's 130, isn't it? And then add this one. What would that be? 130, 214. Take away 16, 198. However you want to add it up. You can obviously put it in column addition format if you want. So we've got these two. And then, so the total surface area is both of those added, isn't it? 198 plus 80 should give you 278. Okay, so surface area is just the area of all the outside faces added together. Just make sure there's nothing that's technically an overlap or nothing that's technically on the inside of the shape. You don't want to include that. Okay, question 10. The table shows some information about the profit made each day at a cricket club on 100 days. So we've got another frequency table, but now this frequency table is actually being used in the context of cumulative frequency. This is another topic that is just really easy marks if you just memorize what to do. Okay, really easy marks. So complete the cumulative frequency table for 1 mark. So you see how the frequencies, you can kind of compare the two tables, see how they're different. Do you see how the first one is 0 to 50, then it's 50 to 100, 100 to 150. They're all separate, aren't they? Each row is a separate category. And then if you look at the cumulative frequency table, do you see how they all start from 0? So it's 0 to 50. And then the second one is 0 to 100. So that would include 0 to 50, wouldn't it? And then 0 to 150 includes the previous two. So cumulative, just as a general word, is every time you're adding more, or every time you're including more. So it's only 1 mark because it's really straightforward. You just need to add up the rows, as in, obviously, see how the first row is exactly the same, so that's still 10. And then the second row, do you see how of the original table, if I get my highlighter, 0 to 100 is 0 to 50 and 50 to 100. So you see how that would be both of these together added. So that's 25, isn't it? And then the next one down is 0 to 150. So see how that would include the first 3 rows. So I need to add another 25. So that's 50. Then I need to add 30, which is 80. And just add every time another row. Really, really, really easy. 85 and then 100. So your final row should technically total, if they've given it to you in the question, the total number. So they said 100 there, we've also got 100, so I know that I've obviously done the calculations correctly. Now, we're going to need to use this in the next page. So I'm going to just copy, I'm going to try and print screen the table just so I can refer to it. So it's going to let me paste. There we go. So I'm just going to put this here. Obviously, if you've got it in front of you, then it'll be kind of like the left page and the right page, so you won't have to flick between them. So part B, if they normally get you to do the table, they're also then most likely going to get you to draw the graph, which is also really straightforward, 2 marks. The only thing you need to know is in terms of the x-axis, what are we plotting? It's always the numbers on the right of the range. Okay, it's always these numbers. It's not a midpoint. That's not the same topic. That's called frequency polygons, which sounds similar, but that's a different topic if you work at the midpoints. This one is just the right-hand side. So, for example, the first one I need to plot 50 along, 10 up. Just double check your scales as well. Then I need to do 100 and 25. So that one's 30 here, isn't it? Just be careful of the scale. That's 30. So actually 25 is like about here. 50 is this one. And then 280. And then 250 and 85. Again, just be careful with that one. And then 300 and 100. And your graph, your cumulative frequency graph, should always be increasing. Okay, it shouldn't go back down again. If it goes back down again at some point, something's wrong. Sorry, for the question, is it calculator? This is non-calculator. So we can't, that's why I'm not using a calculator for this exam. This one is a non-calculator paper, just so you know. Now, we obviously need to join up these points, and a cumulative frequency graph is also another curve. So don't use your ruler, it should be a curve. Oh, I normally start from 0 as well. I'm going to try and do this as best I can. There. As I said, also, if you're going to do it, use a pencil just in case you need to rub it out and try it again. Because we're going to be using this graph in our part B and part C and part D, so you want to draw it roughly, as accurately as you can. There, something like that. That's what it should look like. It should be continually increasing. So part C, use your graph to find an estimate. It's an estimate because, again, it's not drawn very accurately, and also our numbers are just rough within a range, aren't they? So we don't know the exact numbers. So it's an estimate. Find an estimate for the number of days on which the profit was less than £125. Now, because they've given us £125, we need to start on the axis that is in pounds, which is the x-axis. So as long as you know which axis you're working from, that's the most important thing. So you'd get your ruler, obviously a pencil, and 125. 125 is exactly halfway between 100 and 150, isn't it? So make sure you're drawing your line here. not sure why my line is so big, but yep, there. And then obviously once it hits your curve, that's when you draw a line across. And because they're asking for the number of days, that is the cumulative frequency, isn't it? In this context, cumulative frequency for this question is the number of days. And then you read that off. So what's that? 32, 34, maybe 35 on my one. Again, they will give you a slight range of possible answers, just because your curve line might be slightly different to mine. So I'm going to go with 35. They have said as long as you get between 35 and 39, they'll accept it. Okay, so as long as you've got something between those, that's fine. So 35 days is what I got. And then part D is now the opposite. So use your graph to find an estimate for the interquartile range. Another really easy question as long as you memorize what you're supposed to do. So interquartile range, we obviously need to know what that is the difference between the upper quartile and the lower quartile, because it's literally a range, isn't it? Now the upper and lower quartiles, we need to know what those are. The upper quartile is 75% of the cumulative frequency. So median, upper quartile, lower quartile, always start from the cumulative frequency axis, from the y-axis, and go back across and then down. Because you see how our answer, I don't know if you can just about see that, our answer is in pounds, so we want to be reading off of the x-axis, so it's the opposite of part C, isn't it? And the lower quartile is therefore 25%. If you were to work out the median, because they can ask that as well, that would be 50%, which is the middle, isn't it? So when I say 75%, 25%, you might think of it as 3/4 and 1/4, that's also fine. I'm talking about the total, so the total frequency. In this case, it's 100, isn't it? Don't necessarily read it off the graph. Sometimes the graph isn't, like, it looks like there's a total, but it's actually not. Just make sure it's from the question. So remember, if we come back here, do you see how we circled 100 days? That was the total frequency. So they've chosen that quite nicely because this is obviously non-calculator. 75% or 3/4 of 100 is obviously 75. And 1/4 is 25. So that's what I'm going to do on my y-axis. Let me see if I can make this a bit thinner. Going to do a different colour just so you can see that this is part D. So at 25, just be really careful we get the right thing on the graph, because the 25 is kind of halfway between, isn't it? Is here, which is actually one of my points, wasn't it? It was one of the points that we plotted, so you should obviously use the same value, which was at 100, wasn't it? So your lower quartile, this is the lower quartile here, is 100. And then the upper quartile, we said to look at 75, didn't we? So 75, so this is 70, and then halfway, so again halfway kind of between that square there. And then, oh, let me try and draw it. This is what I got. Again, you might have a slightly different value because your curve might be slightly different to mine. So we've got to figure that out, haven't we, there? So I know that this is 175. This is our upper quartile. And so each square, each small square represents 5, doesn't it? Because we've got 25 divided by 5, which is 5. So that would be 180, 185, 190 is what I got. 190. That's what I got. You might have something slightly different, but that's okay. So we now need to subtract. Obviously, the upper quartile, I got 190, and the lower quartile got 100. Obviously, well, technically everyone should get 100, right? Because it's from the table. And that obviously gives me 90. So that's my interquartile range. Now, they've obviously given a possible range of answers. As long as you got somewhere between 85 and 93. When I drew it on a piece of paper, I got 85, so you could get different things, you know. As long as you got anything between 85 and 93, they'll accept that. But the cumulative frequency is very consistent. It's quite, like, the question variety is kind of the same every time. Well, as long as you've covered all the possible questions that they could ask, then you're covered for anything, really, for cumulative frequency. So that's why I say it's quite a nice question, because look, 6 marks, and that was really straightforward. You know, once you know what you're doing, that's really, really straightforward. So another really nice topic cumulative frequency is. Okay, question 11 So we've got some ratio and probability now. Cormac has some sweets in a bag. The sweets are lime flavoured or strawberry flavoured or orange. In the bag, the number of lime sweets to the number of strawberry to the number of orange is in this ratio 9 to 4 to x. So I like to just put my initials here just so I can refer back to it more easily. L to S to O. Cormac is going to take at random a sweet from the bag. The probability that he takes a lime flavoured sweet is 3/7. Work out the value of x. So we need to create an equation. Whenever they say work out x, you pretty much need an equation, don't you? Now, this one isn't probability trees because you see how he only took one sweet. So I don't need to draw a tree. I only draw trees when there's maybe taking 2 sweets out of a bag, or there's 2 things or 3 things. In this case, there's not, so I don't need to worry about that. The probability of getting a lime sweet, if I look at the ratio, is 9 chances. You've got 9 chances. I'm not saying there's 9 actual sweets, but in terms of this multiple, there are 9 chances out of all of the sweets, aren't they? So all of the sweets would be 9 plus 4 plus x. See how I could create that as a fraction? That's another way of saying the probability of getting lime. And then I could equate that to 3/7 because that's also the probability of getting lime. So that's my equation. Now I just need to solve for x. So obviously I'm going to add that. That's 13 plus x equals 3/7. Now what I like to do is cross multiply. You can do it in 2 separate steps. I like to just straight away do it in 1 step because it's not too complicated, this one. So as in multiply by the denominators to cancel them out, because obviously you can't really solve an equation if you've got fractions. So that'd be 9 times 7, which is 63 on the left, and then on the right it's 3 multiplied by 13 plus x. That looks a bit better now, doesn't it? We've just got a linear equation to solve at this point, so obviously I'm going to expand the brackets. 39 plus 3x. I'm going to subtract 39 from both sides, which gives me 24 is 3x, and now divide by 3. So you should get 8. This one is just maybe a little bit tricky because you have to create the equations first. Okay, question 12. This is yet another really easy question as long as you know the actual steps, as long as you obviously are just familiar with this topic. So express 0.117 recurring as a fraction. So this is converting recurring decimals to fractions. That's the topic. Really, really nice question as long as you know the method. So we start off by saying let x equal whatever the decimal is. Okay. So that obviously changes depending on the question. Then you need to create 2 versions of this where we are isolating just the recurring part of the decimal. Do you see how the first 1 is not recurring? It's just the second 1 and then the 7. Those are the only 2 digits that recur. So I want to get that first 1 out of the decimal. So you're going to basically either multiply by 10, 100, 1000, whatever you need to get it out of the decimal. In this case, obviously, I just need to move it by 1 decimal place, which is multiplying by 10. So I would have, obviously, both sides multiplied by 10. 10x is the same as 1.17. Do you see how now I've just got the recurring part of the decimal isolated? Now I need 2 versions of this, though. So not just 10x in this case. How do I then get the same recurring decimal again? Now it can't be, I can't do 11.71 recurring by timesing it by, that would be 100x, wouldn't it? I can't do that because I need to have the recurring decimal in the same order as well. So I'd have to skip it again by another 10, wouldn't I? And what I mean by that is obviously we would need 1000x. So each time it is different, whether you need 10x, x, 100x, 1000x, it is different depending on the decimal, but as long as you can figure that out, then it's fine. I tend to write the bigger one above. So I need to multiply this by another 100 to get another version of that decimal repeated, don't I? So times both sides by 100 gives me 1000x, times in this equation, not not the original x. And then that would give me 117.17 again. Do you see how I've got two versions? Ignore that original x, we don't need that one anymore. Do you see how I've got two versions of the equation where I've got the same recurring decimal in the same order, isolated? That's the whole point. Now what you want to do, once you've figured that out, depending on your question, is subtract, which is why I wrote the bigger one above, just so it's easier. Subtract the equations of both sides. So 1000 take away 10 is obviously 990 x. And then this side, it looks complicated, but it's really not, because the fact that we isolated in the correct order the same decimal, those are just going to cancel each other out, aren't they? So it's not like a complicated subtraction. But remember, in this case, I've now then got 117 minus 1, which gives me 116. And then the last thing you want to do is, because we originally said x is this recurring decimal, I want to solve this equation for x again, which obviously means I need to divide by whatever coefficient you have. In this case, it's 990. And the logic is, if we've said originally that x is the recurring decimal, and then we've also now mathematically worked out that x is also 116 over 990, do you see how they must be the same? So it's just converting into a fraction. Now, this one, they actually, when I looked at the mark scheme, they haven't actually, they've given that as an answer, that's fine. Because they didn't specify that you had to simplify it, but I feel like naturally we kind of want to, so the way to simplify it is it actually only divided by 2, which is, I mean, not too difficult. So you can write either 116 over 990 or 58 over 495, whichever of those two is the correct answer, that's fine. So again, another really nice one, as long as you just know that method. Okay, question 13. This is the one where I think probably threw a lot of people, because this is kind of like a proof one. I feel like these are the really random ones that are, you might not necessarily know what to do, because they are quite niche. So, question 13. A right-angled triangle was formed by the diameters of 3 semicircular regions A, B, and C, as shown on the diagram. We need to show that the area of A is equal to the area of B plus the area of C. And we've obviously got a right-angled triangle. So you might initially just be like, well, this is obviously something to do with Pythagoras, which is true. Having looked at the mark scheme, there's a lot of different ways you could solve this. So I'm going to show you what I did. If you did it a different way, you can also check the mark scheme and see if your answer is also fine, because they had like 3 or 4 different options. So you can use, we kind of need to create letters for the side lengths. So you can use A, B, and C. You can use X, Y, Z, or any 3 letters. They even suggested that you could actually just put numbers to it if you know what a Pythagorean triple is. A Pythagorean triple are obviously the 3 sides, but where they're all whole numbers. So for example, a Pythagorean triple is 3, 4, and 5. You might have seen that before. 3 squared plus 4 squared does equal 5 squared. So that's quite a nice one. And any multiple of that, so 6, 8, and 10 works. That's also a Pythagorean triple. So you could use numbers as well if you wanted to, instead of letters. That's also fine. Obviously use those numbers because they're whole numbers and this is non-calculator. I think I used X, Y, and Z just because I feel like I was going to get confused using A, B, and C, because with Pythagoras' theorem, this one is normally C, isn't it? And I felt like I'd probably get mixed up because they put A, B, and C in the wrong order. So you can use that, but just make sure you get it the right way around. I actually just used X, Y, and Z, so it doesn't really matter which is which. X, Y, and Z. What they've said is the first mark, because this is a proof, so I feel like it's quite handy to know exactly what the mark scheme says, is they said the first mark is for use of Pythagoras' theorem with any of those letters, or also with 3, 4, and 5, if you use those numbers. So you could say x squared plus y squared in terms of Pythag does equal z squared, doesn't it? That's just a mathematical fact. Then the second mark is for working out the areas. Now I'm going to obviously use X, Y, and Z. Also just be aware though that obviously those are the diameters, aren't they? And area of a circle is half the diameter. It's pi r squared, which is the radius. So you need to half these, but also it's a semicircle, so we need to half the area. So this can be a little bit complicated, I guess. So let's say area of A, for example, would be, I need the pi times the radius. The radius is z over 2 squared. Now that's the whole circle, so that's over 2 as well, isn't it? And then do exactly the same for your other two. So B, area of B is pi y over 2 squared, and then all of that halved. And then the area of C is pi x over 2 squared. Again, if you didn't use A, B, and if you used A, B, and C, obviously do that. If you used numbers, use the actual numbers. But as long as you've used this formula, that's fine. And then what we're going to do is just sub that into their formula here. So they said the region, area of region A. Just don't get confused with the Z and the 2's there, that's a Z. Is equal to the area of B plus the area of C. So add these together. Over 2 plus this one. And then what we want to do in order to show that it's a fact, that it is true, is see if we can rearrange this to get back to Pythagoras, because we know Pythagoras to be true. And this is effectively just a rearranged version of Pythagoras, which also makes it true. So what I thought when I looked at this was, I can just cancel out all the pi. Like if you were to divide by pi, because they all have pi in them, all of these three terms have pi, that just cancels. Then I thought, okay, if I times by 2 across the whole equation, again, that would cancel out all the 2's, wouldn't it? And then I thought, let's actually square them. So z squared over 4 equals y squared over 4 plus x squared over 4. And again, do you see how now they've all got 4 as a denominator? So then I thought, right, if you were to multiply by 4 across the whole equation, that would also then cancel out the 4's. And then you see how you're left. I know it's in a different order, but it doesn't really matter. Z squared equals y squared plus x squared is the same as the original Pythagoras, just written in a different order. It's the same thing. Okay, so if this is true, because we know that that is literally Pythagoras, then this version should also be true. That's just a rearranged version of Pythagoras. So yeah, really weird question, very niche question. I'm not sure if they'd repeat something as obvious, like something as specific as this. I don't know if they'd repeat it exactly. But yeah, that's what I would do with that one. But yeah, definitely one is kind of hard. I mean, you literally get a mark for just writing down Pythagoras. If you just wrote down a squared plus b squared equals c squared, I'm pretty sure you get a mark. So maybe you'd have to get the letters in the correct place, I guess. Yeah, I think you'd have to get the letters in the correct place in terms of the fact that they mixed up the letters on the original triangle. But if you wrote that down using the correct letters they've done here, you'd get a mark. That's already 1 mark. Do you see what I mean? So even if you're not really sure how to show anything, you could still get a mark. And all these marks add up, don't they, ultimately? So it doesn't really matter if you don't necessarily answer the question, as long as you've written something or anything that you think is related. I know that Pythagoras is kind of related because we've got a right angle triangle with different side lengths. And I know that the area of these semicircles is related, so you could always write that as well. Do you see how you could probably get 2 marks out of 3 without even showing anything if you weren't sure, but you could just write down anything that you think's relevant to the question. So the area of semicircles, obviously relevant somehow, and then you might have figured out that Pythagoras is relevant too. Okay, question 14. Here is a speed time graph. Part A, work out an estimate of the gradient of the graph at t equals 2. I feel like this is quite a good paper, actually. This is another one where, as long as you know exactly what to do, it's really easy every time. So you can see that the graph we've got is what I would call non-linear. I mean, technically it looks like a quadratic, but more vaguely, non-linear, as in it's not a straight line. It is a curve. And when they ask you to estimate the gradient of some kind of curve at a specific point, you always have to draw a tangent. You just have to know that. And it's normally in this context. It's normally in a speed time context. You just have to know that. Okay, once you know that, then it's really straightforward. So what I'm going to do is draw to the best I can. Obviously, that's why it's an estimate, because everyone's tangent looks different. To the best of my ability, I'm going to draw a tangent at the point t is 2. Before I do that, I'm going to write down the coordinates of t. So that's 2, and then it looks like 2.8, doesn't it? 2.8. Just because when I draw my tangent, it probably won't be as clear. Now, think of a tangent like a circle tangent. It basically is a straight line that kind of skims a circle, or in this case, a curved graph. At one point, it doesn't cross through, it just kind of skims it and then carries on. So let me see how best I can draw. Maybe something like that. You could obviously extend it the whole way through the graph if you want. Something like that. Maybe a bit more vertical. I mean, they're not that fussy, because again, there's going to be a range of possible answers, because everyone's tangent will look slightly different. Maybe like that. Obviously it has to touch, doesn't it? Just the best you can. Obviously do it with a pencil just in case you want to do it again. Being a bit fussy now. Oh no. Okay, that looks a bit better. Okay, I think that's okay. So at t is 2, right? Then I'm going to use that, because that is a straight line. A tangent is a straight line. I'm going to use that to find a gradient. Okay, so change in y, gradient is the m, isn't it? You don't have to write m, but just technically, is change in y over change in x. So that's why I wrote down the coordinates there. I need 2 sets of coordinates from that line, so I tend to use the actual set of coordinates of the point they've given me. You don't have to, but I tend to use that one, because obviously that is the most accurate set of coordinates, isn't it? And then I choose another set of coordinates from my tangent. So anywhere along the line where you feel like there's a set of coordinates kind of screaming out at you. I think I used 1. So as in, like, this is 1, isn't it? And then mine crossed through at, that looks like 1.8, isn't it? Yours might look different, obviously. I know that when I drew it on a piece of paper, I got different numbers. Obviously not far off, but I did get slightly different numbers. So that's my other set of coordinates, 1.8. So change in y, it doesn't matter which order you do the coordinates as long as you match them up. I mean, as in, so I'm going to do the biggest one first. 2.8 minus 1.8. And then, therefore, when I do x, I'd have to match up, see, vertically. The 2 and the 2.8 go together, don't they? As long as you do that. I mean, also you can see by the tangent you've drawn whether it should be positive or negative. But as long as you match them up like that, you'll know that you'll get the correct symbol, positive or negative. You can see obviously it should come out positive by the looks of it. Then we work it out. Now, luckily these aren't too difficult coordinates, because that would be 1 and then over 1. Oh, I've got 1 over 1, which is 1. You might get a slightly different number, that's fine. They have obviously given a range, possible answers. I did get a different answer when I did it on paper. I got 0.9. As long as you get something between 0.7 and 1.1, they'll accept that. Anything between those, obviously everyone's tangent will look slightly different, so that's why the range is a little bit bigger than normal. Okay, part B, what does the area under the graph represent? Normally when it asks for the area under the graph, and obviously double check, oh, what happened there? Let's try and get it back. Yeah, so normally when it says area under a graph, and obviously double check it is a speed time graph, it's the distance. Because think about it, distance is speed multiplied by time, isn't it? I mean, this isn't part of the answer, but just to explain it. Speed is distance divided by time, so therefore, distance is speed times time. And if you were to work out the area under this graph, that's the one where you split it into trapeziums. It's basically the 2 axes multiplied together, isn't it? So that's why. You don't need to kind of write that down. As long as you write down the word distance, Don't even need a full sentence. Literally, the mark scheme just says distance. So that's a nice 1 mark if you can memorize that. Okay, question 15, we've got vectors. So A, B, and C are 3 points such that the vector A to B is 3A plus 4B, and the vector A to C is 15A plus 20B. We need to prove that A, B, and C lie on a straight line. So this is another one. If you memorize how to do it, it's the same every time, whether they've drawn it. Sometimes they give you a drawing, don't they, an actual shape, or in this case, whether they've just told you the numbers. To prove that any points lie on a straight line with vectors, the first thing we need to prove is that they are parallel vectors. Because if you were to cut up a straight line into pieces, they are technically parallel to each other, aren't they? And the way that we prove that any 2 vectors are parallel is showing that they are a multiple of each other. One is maybe a bigger version of the other. And what I mean by that is I want to work out what is the scale factor between them. So I normally do the biggest divided by the smallest. You could do it the other way around, but I normally do it this way around. So as in, compare the A coefficients. 15 divided by 3 is 5. So you see how, in terms of the A's, AC is 5 times bigger. Now, if they're parallel, the B coefficients will also be 5 times bigger. It has to be the same scale for both. So then I can do the biggest 20 divided by the smallest 4. I also get 5. So that tells me that they are parallel. The way that I would word that is I would write it as this kind of equation. So you put the biggest, if you've done it this way around, you put the biggest one equals AC is, then you put your scale factor, 5 times AB, isn't it? And the small one, 5 times the small one makes the big one. And then I go, well, that makes it parallel, so I put a little therefore. Because they're multiples, they're parallel. And this bit here literally explains that they are multiples, right? Because they're multiples, they're parallel. That's the first thing. The last thing is then to prove that not only are they just 2 random vectors that happen to be parallel, but they actually are connected to create one line. And that's the easy bit, because you just have a look and see which letter they both have in common. In this case, it's A. They both have A, don't they? And then I would write something like share point A in common, or however you want to word it. Therefore, straight line, because if you've got 2 parallel lines, but they actually, in this case, they both start from point A, well, they must literally overlap and create a straight line, mustn't they? So if you're trying to prove that any 2 vectors, or well, any 2 points lie on a straight line, first prove that they are parallel vectors by proving that they are a multiple of each other, they have the same scale factor between A and B coefficients. Then, obviously, they should have one of the letters in common, i.e. they overlap. Okay, that's literally it. Again, if you just memorize those 2 steps, you can apply it to any of the vectors parallel proof or straight line proof,